All right, this introduction to bivariate data lesson is jam-packed. We have one last part. It is about the R squared value. It is called the coefficient of determination. We're kind of talking about what is explaining, what is determining, and what amount is being determined. Okay, determining, coefficient of determination. So here we go. Coefficient of determination, R squared. So what this is doing for us is it's telling us uh, the percent or the proportion of the fluctuation that is happening, the varying amounts in the response, such as, say, the variation in the diameter, or no, the cost of a pumpkin, the percent of the, how much the cost of a pumpkin changes, how much that can be explained by the changes in its diameter. Because there may be some other things that have an impact on the cost of the pumpkin. So not just its diameter, but there could be some other things like what? What else plays into it? Well, things like the type of pumpkin, those pretty kind of green princess pumpkins, or the white pumpkins, or whatever, its shape, how pretty it is, if it has blemishes, whatever. Where it's sold. Did you get it at Walmart? $3.98 at Walmart. But when I went and go get the same thing at the farmer's market down the road, it was $6.98 or $6.50. Okay, 2 for $12 is what it was. All right, so here we go. For example, if R is 0.922, look at there. R squared is literally the correlation coefficient represented by the R. R squared is 0.85. So that means that about 85% of what's happening to the response variable, like about 85% of the fluctuation in the prices of the pumpkin, are happening because, or are being explained because of that relationship between the size of the pumpkin and its price, the linear relationship there. Well, guess what? 15% of that fluctuation in the price is to other things. Where you bought it from, what kind of pumpkin it is. Okay? So anyway, that's what's happening. We're able to really talk about what is determining what and how much of it is determined by that. So here we go. Take a look at these. If we have got these correlation coefficients represented by the R, then I'm going to square them, and here we go. So we've got our R squareds, which are literally the R squared. So we always say these in percents. So about, oh, well, let's remember this, that since R squared is literally the correlation coefficient, look, that's wrong. The correlation coefficient R squared, so I said that even wrong. See, I even got it confused when I was doing my notes. The correlation coefficient R squared, then the coefficient of determination is always a positive value between 0 and 1. So then here's an idea of how to do its interpretation. R squared is the percent of fluctuation in the y variable, the variation in the y variable that can be explained by the linear relationship between the two items, or the linear relationship with it. Now, I also have a song that will help us remember this. It goes to Frosty the Snowman. Here we go. We've got, if it is 100%, then the linear model is completely explained by that pattern. If we have, maybe if R squared is just 0.72, then it's some of it. It's not all of it. It's not explaining all of it. Okay, so let's move on. And I think next, here comes our song. Coefficient of determination, the percent of variation that is found in the y. So we're always talking about the percent of variation that is found in the y. Coefficient of determination, the percent of variation that is found in the y. Okay, now look here. It can be explained by the changes in the x, or it can be explained by the model itself. Now, when I say the model itself, that means the linear relationship between x and y. That's what the model is the linear relationship between x and y. So, coefficient of determination, the percent of variation that is found in the y. Okay, here's an example. About 62% of the fluctuation in egg production from white leghorn chickens can be explained by the varying ages of the chickens. Okay, here's another way to say it. About 62% of that variability in egg production from the white leghorn chicken can be explained by that linear relationship with the age of chicken. So there we go. All right, so let's do our interpretations of our examples. These are the same examples from when we did the interpretation of the R value, the correlation coefficient. And so this here we are talking about the price of the pumpkin versus its diameter, how big it is. Okay, but if we want to do R squared, let's talk about what that means. So R is 0.7. Therefore, what's R squared? 0.49. Okay. Now, R squared is always going to be stated in percent of variation in the Y. So think about that. Our Y, of course, is that price per pumpkin. So about 49% of that fluctuation or that changes in the price of the pumpkin can be explained by the various diameters of the pumpkin. Okay? So we have to have that statement about the variability in the y being explained by those variances, the variation in the x's. The percent of variation that is found in the y, it can be explained by the changes, the fluctuation in the x. So about 49% of the fluctuation in the price of the pumpkin can be explained by those various diameters in the pumpkin. Now, another common way that you're going to see this stated is about 49% of those various prices of the pumpkins can be explained by this model, can be explained by that linear relationship between price of the pumpkin and diameter, price of and diameter of the pumpkin. So either one of those is acceptable. You will be exposed to both of those, and you need to understand them both. A key thing that I watch for that gets missed, about 49% of the fluctuation in the price can be explained by the changes in the diameter. This is the piece that gets left out most commonly. Okay, so make sure those different pumpkin inches, pumpkin diameters explain the different prices of the pumpkins. Hey, well, you know what this means? What's missing? Well, that's telling me that about 51% of the fluctuation or the variation, the fluctuation in the price is explained by other, you know, other other situations, okay, or whatever. Where you buy it from, how pretty it is, what kind it is, that kind of stuff. How many, maybe bulk. Okay, so yeah, 51% is happening because of other things. All right, next one, the grape farm, not the graph farm, and the price per pound it charges its clients. So we want to square the R. That's only 0.09. See how it is positive, always going to be positive. So this is about 9%. So this tells me that only about 9% of that fluctuation in the price that it charges its retail clients, only about 9% of that variation in the what it charges its retail clients is happening because or is explained by those sizes of the farm. Small farm versus a big farm. Okay? Only 9%. 91% is happening because of other things. I don't know what those would be. Location, the relationship you have with the clients, whatever. Okay? How about this? Also, about 9% of that variation in the price per pound charged to its retail clients can be explained by the linear relationship between the size of the grape farm and the price per pound charged. All right, a lot of information. So, if you take a look then at your assignment you're going to be doing here, you will have to take a set of data, put it into your calculator, make sure that your diagnostics are on. If you don't know how to do that, go to part 1 video so that you can state what the slope, y-intercept, r, and r squared are. I think I actually even wrote that backwards than how it comes out in your calculator. Calculator shows r squared on top of r, so be careful when you are putting that down on here, okay? Then, state the explanatory and response. Write the least squares regression line in context. And do not forget the prediction hat. Remember that you needed the prediction hat and all the important things that you need to talk about, how this is the slope. The interpretation of the slope has to do with the predicted response value, the predicted y value, not the actual. So go back to your notes. Interpret the y-intercept, and then interpret the correlation coefficient R, and interpret the coefficient of determination. So lots of phrases, lots of songs, and so you do that twice. Okay, here's the other one. And then after that, some very interesting information. This is real data about a sensitive topic, so hopefully this is not going to disturb you too much, having to do with the rise in public mass shootings. But talking about the debates going on between the explanatory variable for that is it some people say it's how much, the accessibility, the rifle production. Let's stop the rifle, or how hard it is to get one. Your mental health disorders, also been that, and video game sales, the violent video games or whatever. So, some very interesting thing that R squared tells us about that we are going to want to discuss. And so, there you go. All right, that is it. Jam-packed lesson on your introduction to bivariate data.